This is a video of my critical circuit emergency power system. It utilizes two AFRI P310s as both the primary uninterruptible power supply and transfer switch, and a second one is a secondary power supply. The way this system works, and this system is composed of, believe it or not, 4 transfer switches, 2 of which are in the 2 AFRIs, and then there is a transfer switch right here that also turns on the generator, and then there's a 30 amp switch right here, and there is a manual transfer switch along with the 3 automatic transfer switches. Essentially, this entire system supports internet, living room internet, and the everything that's associated with the internet, along with 6 circuits we've deemed to be emergency circuits, and they are the refrigerator, the heating system, basement lights, the water pump, the wood circulator, which has now become an auxiliary circuit, and the living room. And essentially the way it works is in the event of a power outage that affects the 6 critical circuits and the internet, the system automatically defaults to the secondary. Essentially everything's running off of this primary, which is powered by the grid. So this is the primary power for the system. Right now it's consuming 208 watts, and it's bringing in 208 watts, which means it will live forever. When the power goes off, this thing kicks in, the AFRI P310 kicks in, and it is powered when the power goes off by the power that's coming from the automatic transfer switch right here, and because that also is activated, and the automatic transfer switch gets its power primarily from this battery bank of 8 batteries and a 4,000 watt inverter. So the power goes out, the automatic transfer switch is turned on, the secondary P10 picks up the load, but it isn't using any of its batteries because it is being charged on a pass-through from the 4,000 watt inverter. If these batteries are depleted below allowable voltage, which I think I've got set for 11.5 volts, that will trip the automatic transfer switch, which will then turn on the generator. But because the generator produces dirty power, in front of the output of that, we've got this secondary P10. So the house won't notice anything even with the generator running, but the generator will be running outside. It'll be turned on by the lack of electricity coming from the inverter, and when it trips, it'll turn on the generator. It will also start charging the battery bank again through the generator output port. When the batteries get to 14.2 again, the inverter will take over again, and the switch will reset. It's the switch I built right there. It'll reset, and the batteries will again be providing power, and the generator will shut down. This allows me to individually select the critical circuits to determine which ones I want on. When I leave the house, I leave all of the circuits on generator. Right now, even when we're using the house, we leave it on generator because essentially it's a pass-through from the grid to that unless there's a power outage. So power outages occur. We're in business. Everything, all the critical circuits run, and pretty much we can operate as if there's no problem. I've got this other backup battery here just in case for some reason I need power someplace else. It's also being charged along with it, with everything else. That's it. That's the Mike Roberts. There's all sorts of monitoring I've put on here. I'm using this this switch right here, which is a Wi-Fi switch, but it's also an energy monitor. And what that allows me to do is look at all the places where energy is being consumed. I can take a look at it in real time. So that's the system. Seems to work very well, and I'm very pleased with it.